We're going to start writing some numbers in other bases. So whenever we see a number like this, of course, if it doesn't have a base written, we assume it's in base 10. So we're assuming that this is 37, or basically 3 groups of 10 and 7 units. So we want to convert that number into base 5. So I'm just going to start grouping in groups of 5, right? So I have, I'm going to count to 37. Here's 1, 2, 3, 4, 5. Now that's a group of 5, so that becomes a rod. Now 6, 7, 8, 9, 10. That's another group of 5. And I can kind of shorten this a little bit, right? So I've got another group of 5 that I could fit in there. So that would get me to 15. And I could put another group of 5 in there, so that's going to get me to 20. And another group of 5, so it's going to get me to 25. But you'll notice now that I actually have 5 rods. So since we're in base 5, anytime we get 5 of something, we regroup. So when I had 5 units, I regrouped as a rod. Now I have 5 rods, so this becomes a flat, or a group of 25. So this is one group of 25, or one flat. And then let's keep going. So far I've counted to 25. Here's 26, 27, 28, 29, 30. There's a group of 5. So that becomes a rod. So now I'm at 30. Let's see, this is 31, 32, 33, 34, 35. There's another rod, since that's another group of 5. And then let's do 36, 37, and that's what I was counting to, was 37. So I can see here that I have, in terms of groups of 5, right, I have actually 7 groups of 5, but what happened is 5 of those got regrouped. So what happens when you get 5 groups of 5? It becomes a flat, or a group of 25. And so in this case, I can see that I have one flat, or one group of 5 squared, or one group of 25. I have 2 rods, or 2 groups of 5, and I have 2 left over. So the number I would write here, don't forget the subscript. This is 122 base 5, and that's how we would say that. We would not say that as 122. We would say that as 122 base 5. So there were 2 units left over after we grouped everything into groups of 5. And then when we had 5 groups of 5, that got regrouped as a group of 25. It did ask here, how many digits do we need to write numbers in base 5? So this should always be the same as the base. So we need 5 digits. Now, what are those 5 digits? Well, you always need a symbol for 0, and then you'll have a 1, a 2, a 3, and a 4. You won't have a symbol for 5, because as soon as you get 5 of something, you regroup, and so then it becomes one group of that and 0 left over. So we need the digits 1, 2, 3, 4, and 0 to write numbers in base 5. So then let's do the same thing with this number. So this is the number 77, but this time we're going to do base 6. So it's going to be the same idea. It's just instead of groups of 5, we're going to do groups of 6. So I could just start by just counting. So 1, 2, 3, 4, 5, 6. And as soon as I get 6 of them, since I'm in base 6, that becomes a rod. And then let me speed this up a little bit so I know 6 more would give me 12. So let me just go ahead and put another rod in there. So now I'm at 12. So I can just count by 6s. So let's do another 6. That would be 18. And then I'll squeeze in another 6 over here. So 6 times 4 would be 24 so far. Then 6 times 5 would be 30. So I'm counting to 77 so far. I'm up to 30. So let's see, I've got 5 rods so far. Let's do another one here. So then 6 more. So 6 groups of 6. So that's 36 so far. But we're in base 6. So as soon as you get 6 of something, we regroup. So now that we have 6 rods, this becomes a flat. So now I've got one group of 36 or 6 squared. So I've got one flat. So we want to just keep doing this. So right now I've counted to 36. I would just keep adding units. So 37, 38. We can maybe do this a little bit faster though. This is the flat in this case is 6 times 6 is 36. Could I get another group of 36 into that? Absolutely I could, right? So if I put another flat or another group of 36, 36 plus 36 is actually 72, right? So I could just go ahead and skip to that just to let it go a little faster. So this is one group of 36, two groups of 36, or 72. And so now I'm counting to 77, so let's keep counting. So this would be 73, 74, 75, 76, 77. And I actually don't even have enough for another rod there, right? I would need 6 of those since I'm in base 6. So that's it. So I can see that I have 2 groups of 36. It wouldn't hurt, and I would encourage you to go ahead and mention your rods. We don't have any. So I would say I have 0 groups of 6 or 0 rods. And then we have 5 left over. So that means we would have the digits 2, 0, 5. You can see why I mentioned the 0 because you don't want to forget to put that in there. And this is in base 6. So this would be 205 base 6. It asks here, can you find a faster way to do this than with blocks? And we kind of already started with that. But we could probably do this without even drawing the blocks. So once we figured out that a flat was 36 units, we just said, could we get another 36 into that? So really what we were doing is we were taking our number, in this case 77, and we were seeing how many groups of 36 can we fit in 77. That's really just division. So if I did 77 divided by 36, that goes in twice, right? 36 goes into 77 twice because 2 times 36 is 72. And so then what I had left over was 5. Now, technically, what we said there is that there weren't enough to regroup that, right? There wasn't enough to get any rods. What we were technically doing there is we were taking what was left over, the 5, and seeing, can I get a group of 6 out of that? So can I divide 6 into that evenly? And it turns out you can't. So how many times is 6 going to 5? It doesn't. It goes in 0 times, and 0 times 6 is 0. So you still have those 5 left over. And then in terms of how many ones do you have, right? Well, how many times does 1 go into 5? It goes in 5 times. So 5 times 1 is 5. And that gives you 0 left over. So if you look at these numbers here in this long division, that's our answer. So the quick way here is long division. And it's just faster than having to draw pictures, right? The pictures are a really nice way to verify this and certainly to explain it to students first figuring this out. But eventually we could just do long division and not have to draw all these pictures. So let's do the next one that way. So we want to write this number 52 in base 3. So it's important to know first what our place values are going to be. So always we start with the ones place, right? But then, so 1 is coming from, in this case, we're in base 3. 3 to the 0 power is just 1. Anything to the 0 power is 1. So we always have the ones place. And then in base 3, we would do groups of 3, right? So we would have the 3's place. So that just comes from 3 to the first power, right? Since we're in base 3. In our system, it's base 10, so it's 10 to the first power, which is the 10's place, right? Then if we get 3 rods, we could put those together to make a flat, that would actually be 9, right? Because we would have, so I'll draw the picture and then erase it. So like we know if we had 3 units, that would give us a rod because we're in base 3, right? But if I do that again, and then again, if I have 3 rods, that makes a flat. Well, if you look at that, that's actually 9 units, right? And that 9 comes from 3 squared, right? 3 to the second power. And we can keep doing that. So we just keep raising the power of 3. So 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9, 3 to the third power, or 3 times 3 times 3, would be 27. So if we were to regroup as the big cube, that would be 27. And then 3 to the fourth power, that's 3 times 3 times 3 times 3. That's actually 81. And like, how far do I need to do this? I do it until it's too big, and this one is too big, right? 81 is bigger than the number I have, which is 52. So that one's too big. So really, I could just start with the 27. But that's the idea, is let's just do this with long division. So if we have groups of 27 or groups of 3 to the third power, right? How many groups of 27 can I get out of 52? Or in other words, what's 52 divided by 27? I think it only goes in once. It's really close, right? Because like what 27 times 2, I think is 54. So it's close, but it only goes in once, right? So 1 times 27 is 27. If we subtract that, that leaves us 25 left over. So that means that I can get one group of 27 out of that. And now I have 25 left over. So then I would go to the next thing down. So I did groups of 27. The next one down will be groups of 9. So how many groups of 9 can I get out of the 25 that are left over? Well, I believe that goes in 2 times, because 2 times 9 is 18. And if I subtract that, that's 7 left over. So that means I have 2 groups of 9. And then I would take what's left over there, the 7, and say, okay, move on to the next one. So now I'm moving on to my rods. How many groups of 3, or how many rods can I get out of that? Well, 3 would go into 7 2 times. 2 times 3 is 6. Subtract that, I get 1 left over. And then finally, I'm just in the ones place, or the units. So what's left over? So you could probably skip this last long division if you wanted. So you're basically just taking what's left over and dividing it by 1, which would just give you 1, right? But like we can see that this is the number in each place value. So you can see that we have 1 left over in the ones place. We have 2 rods, or 2 groups of 3. We have 2 flats, or 2 groups of 9. And we have 1 big cube, or 1 group of 27. So you just take those numbers and write them down, 1 2 2 1, and then we're going to write our base, which is base 3. So that's it. That would be the equivalent of 1 big cube, 1 flat, 1 rod. I'm sorry, 1 big cube, 2 flats, 2 rods, and 1 unit. All right, let's do this one more time with base 12. So base 12, we would have the ones place and then the 12s place, right? So the ones place would be my units. Then if I get a group of 12, that would give me a rod, right? If I had 12 groups of 12, or 12 squared, that would give me a flat, and 12 squared is 144. I'm going to go ahead and do the multiplication for you on this. So 12 cubed is 1,728, right? And that looks like it's okay. That will still go into this number. So that goes into 2,597. And then, so technically I should go ahead and check 12 to the fourth power, and I'll do that multiplication for you. 12 to the fourth power is 20,736, and that one is too big, guys. So that one is where we could stop and say, I'm actually going to start with the 1728, because 2,597 is definitely smaller than 20,736. So I'm going to take the number that we start with, 2,597, and I want to divide that by the highest power of 12 that will go into that, which is 1728. And I'm going to guess and say I think that only goes in once. So let's see if that's right. So 1 times 1728 is 1728, and then I'm going to subtract. So let's see. Oops. 869, yeah, so that's right. So, because there's 869 left over, so there's not enough left over for 1728 to go back into that again. So that means that there's one group of 1,728. So then I take that remainder, 869, and I'm going to divide that by the next power of 12, which is 144. So how many times does 144 go into 869? Let's see, I'm thinking 144 is close to 150. 150 would go into 900 like 6 times. So I could try 6, or maybe I could try 5. If I try something that doesn't work, it's just going to show me what would work. So I'll try 6 and see if it works. It's just a guess. Let's see, 6 times 4 is 24. 6 times 4, again, is 24, plus 2 is 26. 6 times 1 is 6, plus 2 is 8. So yes, that actually does work. That goes in. It's not bigger than 869. So like if I had tried 7, I would have gotten something bigger than 869. So that would tell me that doesn't work. If I had tried 5 there, I would have had a number when I subtract. I would have had a number left over that's bigger than 144, which would let me know 144 could go into it an additional time. So that was the correct choice, and my remainder now is 5. So I'm going to have 6 groups of 144. So then I'm going to take the remainder of 5 and divide that by the next power of 12 down. So that would be 12. So 5 divided by 12, how many times does 12 go into 5? It doesn't, right? 12 doesn't go into 5, so that's 0. 0 times 12 is 0. 5 minus 0 is 5. So there are 0 groups of 12. And so then this last one, again, you could probably skip if you want, but we're going to take the remainder, which was 5, and divide it by the next power of 12, which is 1. 1 goes into 5 times. 5 times 1 is 5. Subtract and you get 0, and that means that I have 5 left over, or 5 groups of 1. So this means I have 5 groups of 1, or 5 units. I have 0 groups of 12, meaning I have 0 rods. I have 6 groups of 12 squared, so that means I have 6 flats. Then I have 1 group of 12 to the third, which means I have 1 big cube. So 1 big cube, 6 flats, 0 rods, 5 units, and then don't forget to write the 12 next to that. So that's in base 12, 1605, base 12. All right, and then the last question here just asks, what is the purpose of doing this in an MAE class? So you could see lots of advantages to this, like, hey, we got some practice with some long division. We got some practice with some multiplication. We practiced drawing rods and units and flats, right? Really though, the purpose of this is we want to put you in the shoes of a first grader. So you've been doing base 10 for so long that this idea of like, once you get 10 of something, you regroup it. And then once you get 10 of that, you regroup it. It's so ingrained that you probably don't remember learning it, and you just are used to doing it without thinking of it. So this is to kind of make you realize that to someone that hasn't seen that, to a first grader who is not used to the base 10 system, that's a very foreign idea. So like making you do these other bases really puts you in their shoes. It really makes you think about what it means. Like we're just used to 10, and 10 is a really easy base to do, right? But this makes you think about like what you're doing and why. A lot of times we carry and we borrow without really thinking what we're doing. We're really saying every time we have a group of 10, we regroup. So this kind of makes you think about that by giving it to you in other bases.